Hello everyone. Today we will discuss about normed linear space. Normed linear space. Generally, we denote norm by the symbol this. So, the definition of a normed linear space is, first we have to know the definition of a norm. A norm on a linear space X over the field K. K may be C, that is the set of all complex number, or R, that is the set of all real numbers, is a function, that is norm is a function X goes to norm X, where X belongs to capital X. This function defined from X to the set R, that is the set of all real numbers, such that it must satisfy following conditions, that is, for every X y belongs to capital X and alpha belongs to K, that is the set of all scalars, which may be set of all complex number or set of all real numbers. The conditions are norm X greater than equal to 0 for all X belongs to capital X, and norm X is equal to 0 if and only if X is equal to 0. Second, norm alpha X is equal to mod alpha into norm X. And the third condition is norm X plus Y less than equal to norm X plus norm Y. The third condition is known as triangle inequality. This is the basic definition of a norm, and X together with this norm is called normed linear space. Linear space, that is NLS. This is the short form of normed linear space. For example, on R2, let X small y belongs to R2. Here norm X is equal to root over x square plus y square. This is a norm on R2, and R2 together with this norm is a normed linear space. And remind that norm on a space is not unique. On a space is not unique. That is, we can define many norms on a particular space. On R2, this is also a norm, is equal to maximum mod x mod y. This is also a norm on R2. And R2 together with this norm is also a norm linear space. But this norm x is equal to minimum of mod small x mod small y is not a norm on R2. Why? Because if we take x is equal to 1, 0, which belongs to R2, now norm x is equal to minimum of mod x mod y, which is equal to minimum of 1, 0, which is equal to norm x is equal to 0, but x not is equal to 0, which violates the condition of norm. The first condition, that is norm x is equal to 0 if and only if x is equal to theta or 0, violates here. So this is not a norm on R2. Similarly, if we take the space C closed AB, that is the collection of all continuous function on closed A comma B, the norm on this space is norm F. It is denoted by norm infinity, is equal to supremum of mod Ft, where T belongs to closed AB. Now, using the definition of norm, we can define a function d from x cross x to R by d of xy is equal to norm x minus y. This d forms a metric space. Now, if x with respect to the metric d is complete, that is, every Cauchy sequence in X is convergent with respect to the metric D, then X D is called a complete metric space. And then X is called a Banach space. This term is very important, Banach space. That is a complete norm-linear space. A complete norm-linear space is called Banach space. Here a very important note is every nonlinear space is a metric space. But every metric space may not be a nonlinear space. Now we can consider a counter example. We take a discrete matrix dxy is equal to 1 when x not is equal to y and 0 when x is equal to y, and dxy is equal to, we assume that this metric is forms a nonlinear space. This metric space forms a nonlinear space. We assume that is dxy is equal to norm x minus y. We can assume it. Now norm x is equal to norm x minus 0. We take x not equal to 0. So x not equal to 0, that is from this metric we say that this is equal to 1. Now take alpha belongs to K, that is set of scalars. Norm alpha x is equal to norm alpha x minus 0. Here x not is equal to 0. This is equal to d of alpha x 0. This is equal to 1. If we assume that this is a norm, then norm alpha x is equal to norm alpha mod alpha into norm x. This is equal to 1. But if we increase the value of alpha, then this equation not always satisfy. So our assumption is wrong. That is, this matrix space is not a nonlinear space. dxy discrete metric is not induced by a norm. We can say it induced by a norm. And also the metric dxy is equal to norm x minus y is translational invariant. That is dx plus z comma y plus z is equal to norm x plus z minus y minus z. This is equal to norm x minus y, that is d of xy. So it is translation invariant. That is all for today. If you like our videos, please do like, share, subscribe our channel for more. Thank you so much.